Okay, so we're going to do a Chapter 4 test review to prepare you for your Chapter 4 test. So we're going to start with some indefinite integrals. So first one, when we take an integral, we're just going to work from left to right. So remember our rule for taking an integral, we're going to add one to the exponent and then divide. So for this first one, if I add 1 to the exponent, that gives me a 3. If I divide 3 by 3, that gives me 1. For 2x, if I add and divide, that gives me x squared, minus, if I take the integral of 1, that gives me x, and then for these, we have to remember to use our plus c. Okay, so number 2. First thing I notice is I have a radical, so I'm going to take some time to rewrite this problem without the radical. I'm going to write this as x to the 1/2 on the bottom. Now the next thing I'm going to do is I want to get separate terms. So I'm going to divide each part on the top by the part on the bottom. So when we divide, we're going to subtract exponents. So 2 minus 1/2 is 1/2, so that's x to the 3/2. I'm going to trade colors here so you can keep track a little bit better. Okay, so for this one, we have plus 2x, and then 1 minus 1/2 would be 1/2. And then for the third one, 1 over x to the 1/2, that would be minus x to the negative 1/2. I'm just going to bring it up to the top, so I'm going to make that exponent negative. Okay, now we're going to go ahead and work from left to right to take the integral. So over here, I'm going to add and divide. If I add 1 to 3/2, that's 5/2. Out in front, we're going to put a 2/5. For the next term, if I add 1 to 1/2, that's 3/2. So I'm going to write that down. Then if I multiply 2 by the reciprocal, so 2 times 2/3 would be 4/3. And then my last term, if I add 1 to negative 1/2, that gives me 1/2. So out in front, I'm going to have a 2x to the 1/2 and then a plus c. Okay, now on to number 3. So before I do number 3, I'm just going to do a little review of our trig derivatives. So we should remember that the derivative of sine is cosine. The derivative of cosine is negative sine. We have tangent is secant squared. We have secant is secant tangent. We have cosecant is negative cosecant cotangent. And we have cotangent is negative cosecant squared. So you might want to write those down. We also have those on our note cards. So if you have your note cards handy, you can get those out and look. I always like to write them down so that when I go to take the integral, we're just going to work backwards. So over here, I'm going to label this the original, and over here would be the derivative. Okay, so let's take a look at number 3. So I'm going to work from left to right. The integral of 3x would be 3/2 x to the 1/2. Now I'm going to look at my chart. I have to take the integral of negative cosine. So I'm going to find cosine, which is right here. So I'm working backwards to take the integral. And it's not a negative cosine. So if the integral of cosine is sine, the integral of negative cosine would have to be negative sine. So I'm going to write negative, and I'm going to bring down the 2 sine of x plus c. You don't really have to memorize the integrals. If you memorize your 6 derivatives, you can easily just write them down and go backwards. Okay, next one, number 4, we're going to find the average value. So there's a formula that we used. That is the integral from a to b of f of x dx, so it's a definite integral, and we're going to find the average in the end by dividing by the difference from b to a, so our distance in between. So I'm going to set this problem up. I'm going to go from 0 to 4. My function is x squared plus 2x. And when I'm done, I'm going to divide by the distance between 0 and 4, so that's 4. Okay, so now I'm going to take my integral. I'm going to bring down this 1/4. I'm going to add and divide all the way across, so that's 1/3 x to the third plus x squared. I don't need a plus c because I'm going to evaluate this from 0 to 4. So now we're going to evaluate. We're going to do top minus bottom, and I'm going to bring down this 1/4. And first thing I'm going to do is plug in the 4. So 1/3 times 4 cubed plus 4 squared minus, now I'm going to plug in 0, 1/3 times 0 cubed plus 0 squared. Okay, so I've got 1/4. Now I'm going to evaluate the part in green first, so that top part that I plugged in. So I've got 4 to the third power, which is 64. If I divide that by 3 and then add 4 squared, which is 16, I get a fraction, 37 1/3. So I'm going to write that as 112 over 3. Minus, this gives me 0. Okay, so last thing I'm going to do is multiply the 1/4 times that, which gives me another fraction. So that is 28/3. Okay, so let's go to the back. We have some u substitution problems to work through. So let's start with number 5. So I don't want to have to do a regular integral here because I don't want to have to take something to the 4th power and then distribute the x. It's going to be a lot of work. So I'm going to find the inside part. I'm going to start with setting u equal to 5 minus x squared. So now I'm going to find du. Derivative of u would be negative 2x dx. So I've got to add in a negative 2 into my problem and take out a negative 1/2 to balance it out. So this works out nice. Now I've got my negative 2x dx, and I've got my u, and I'm left with the little 4 there. So I'm going to rewrite this. Negative 1/2, the integral, u to the 4th du. So now I'm going to take my integral. I'm going to bring down this negative 1/2. The integral of u to the 4th is 1/5 u to the 5th plus c. And you can multiply these together if you like. That's negative 1/10. And I'm going to plug back in for u. So 5 minus x squared to the 5th power plus c. Okay, let's try number 6 next. So number 6, I see a radical. So first off, I'm going to rewrite this. X to the 3rd minus 4 to the 1/4. So I see a u substitution. I see an inside part. So I'm going to set u equal to x cubed minus 4. Du would be 3x squared dx. So I don't have a 3x squared dx, but I do have an x squared dx. So I'm going to add in the 3 that I need and balance it out with a 1/3 on the outside. So now I'm ready to write my new integral. So that's 1/3 the integral. I've got u to the 1/4, and then everything else is du. Okay, so now I'm finally ready to take my integral. I'm going to add and divide. So if I add 1 to 1/4, that gives me 5/4 and puts a 4/5 on the outside. I'm going to multiply these together, so that's 4/15 u to the 5/4 plus c. And the very last step, we're going to plug back in for u, which is x to the 3rd minus 4 to the 5/4 plus c. Okay, number 7, we have a trapezoidal rule. So first thing I'm going to do is look and see how many trapezoids I'm going to get. And I have an n equals 4 right here. I'm also going to look at my boundary. So my graph goes from 0 to 1. So if I just split this up real quick, 0 to 1, I want to split this into 4 equal parts. So that means I'm going to have to go by quarters. So I'm going to label them 0.25, 0.5. I use decimals normally because they're easier to plug in to my calculator when I go to evaluate the heights. Okay, so let's find our first trapezoid here. So I need some heights to get me started. I need the height of 0 and the height at 0.25. So how I would figure those out is I'm going to use my function over here to evaluate the different heights. So the height at 0, if I plug this in, is -5. So it actually goes down here a little ways, -5. And I'm going to get my height at 0.25. So I'm going to use my calculator to plug that in. 0.25 to the 3rd power minus 5 gives me -4.984. We're going to connect those to make a trapezoid. So if I want to find the area of that trapezoid, area of the trapezoid is 1/2 base 1 plus base 2. So I'm going to add those two heights together and we'll round to 3 places. Times the height. So the height is your distance in between. So that would be 0.25. So I'm going to calculate that first area there. That gives me -1.248. So that's my first trapezoid. So I'm going to do my second trapezoid here. So I need to find the height at 0.5. So I'm going to plug that in. That gives me -4.875. Okay, so I'm going to find that area. 1/2, my two heights, -4.984, and then my other height, -4.875, and my distance between the two is 0.25 again. So I'm going to use my calculator to figure that out as well. That gives me -1.232. Okay, my third trapezoid. 1/2. I've got my first base, my first side is -4.875. Now I need my second height, so I'm going to get my height at 0.75. That gives me -4.578. And the distance between is 0.25 again. So I'm going to calculate that again on my calculator. That gives me -1.182. And then my final area, my fourth trapezoid, we've got 1/2. My base on the one side is -4.578. And then my other one, I need the base at 1. So if I plug 1 in, that gives me -4. So I'm going to plug that in my calculator. And that gives me -1.072. So now I'm going to add up all those areas. That gives me negative 4.734. So this is the approximate area. Now, it also says find the actual area. So on your calculator, let's practice finding the actual area. We're going to go to Math, down to number 9 for integral. You're going to type it in exactly how you see it. So 0 to 1. And then we've got our function x to the 3rd power minus 5 dx. Press enter. So the actual answer is negative 4.75. These should be really close to each other. If they're really far off, then you made a mistake somewhere in your trapezoidal rule. Okay, so make sure you know the formula for the area of a trapezoid. I'll write it again up here at the top. Area is equal to 1/2 base 1 plus base 2 times the height. And the bases are the parallel sides. The height is the distance in between. Okay, so that concludes our review for the Chapter 7 test.